All right, in the last video, we opened up our RC car here and cut out the circuit board since we're not going to use it, and made sure that we didn't go too far down into the robot that we accidentally opened the gearbox or took apart something that holds the steering together. We also checked and identified which wires connect to our motors and that the motors work by connecting them to a 9-volt battery briefly, and everything there checked out. One thing we didn't do was look at what's going on with power in this car. So I'm going to open up the bottom here. This one takes a screw to loosen. And it looks like it is a collection of 1, 2, 3, 4, 5 AA batteries. If each of these has 1.5 volts, then that's going to add up to 3, 6, 7.5 volts total. I've got a multimeter handy, so we can use this to see what is the voltage coming out from these last 2 wires. I assume those connect to the batteries there. A lot of cars sometimes won't have the wires coming from the power supply, especially if it's a rechargeable battery type. Oftentimes the circuit board is soldered right to the last metal tabs that come out of that battery pack. In that case, you could check the voltage on that to see if it's got any juice in it. So I've set this to measure DC voltage, and I'll just hold my probes to the battery pack here, and it's coming in less than a volt, much less. So it looks like those batteries are dead. We can go ahead and pop those out, try to get some fresh ones in there. Oftentimes, as you take out old batteries from the thrift store, you're going to find that some have started to leak or corrode. So just be sure to wash your hands afterwards. And that can sometimes cause these terminals to lose their conductivity. So if you find a battery like that, you may need to just get in there with a sharp edge and scrape those terminals clean. All right, I went and gathered up some fresh batteries here, replaced the dead ones. And when I totaled this up and said there was 7.5 volts in there, that's because these are connected in series, end to end, positive to negative. When you do that, it adds up the voltages. So before I close that up, let's just check once again with the multimeter on this black and red wire. See what we read this time. All right, so a few things I did there is I checked in on the switch. There's an on-off switch. And it looks like we're getting close to 4 volts, not the 7 that I expected. Which may mean that these are not all entirely connected in series, though I can see the metal tabs are. If they have some of these grouped up and connected in parallel, then those groups will add their currents together and not the voltages, which could account for the fact why it's coming in a little bit low. Also, it might just be some dirty contacts in there. Yeah, close to 4 volts still. So we'll keep an eye on that and see if we need to dig any deeper in that. But for now, 3 volts should make or 4 volts should make our motors work for the time being. Close that back up. Okay, so an additional step that's going to be really useful is if we take the wires that are here and we extend these out a bit. So right now, looking at the ends of the wires, they're actually stranded core wire. So there's a bunch of really fine copper wires that are all inside the insulation. That is kind of a challenging thing to insert into our screw terminals on our relay module that we're going to use to turn the motors on and off. And sometimes the wires just aren't long enough to get them to where we want everything to mount. So adding some extension is going to be good for that as well. And the extended wire that we can add on can be solid core. So you'll notice that when I bend this type of wire, it stays in that position where the stranded is much more floppy. When we strip this off too, it's going to have a solid end on it that works really well in the screw terminals. It works really well for going into breadboards as well. I'm probably going to pull out about 6 inches for each of these and try to match the colors as much as possible, but not going to be perfect on all of these. So blue and white. For one motor, we got red and black for the power. And brown and green, but I don't have brown, so I'll do green and yellow. All right, so these extensions, to connect them to the wires on the car, we're going to need to do some soldering, and I'll model that for all of these. But to start things off, I need to strip off the insulation from these. I like to do it on both ends right away. We're going to need it stripped on both ends, and it's probably easier to strip them before we have them connected to our car. Stripping off just about the same amount I did on the car there. No more than 1 centimeter. All right, I've stripped it, all my extension wires on both ends here. For soldering, I've got a station set up on my desk right here, and I can just bring over the iron, and the iron itself has in its stand some brass wool cleaner, which I much prefer to the wet sponge. Doesn't shock the heat on the end of the needle there quite as much. I've got a helping hand, which will be very useful, or a third hand here to hold the wires in place as we solder these. I've got some tip tinner, which I find to be very useful for keeping the iron in good condition. We always want it nice and shiny. If you don't have the tip tinner, that's not going to be the end of the world. But of course, then we need some solder to melt into that wire once it's heated up. I try to get this as thin as possible. This here is 0.3 millimeters. And to play it safe, I usually buy the lead-free solder, even though that tends to be a little bit more difficult with its flow. It doesn't have lead in it. The safety considerations, you want to make sure you got some eye protection on. We don't want that liquid hot metal to flick back into our face, and that you're working in a well-ventilated area. The lead-free solder tends to have fumes that are a little bit noxious, so we don't want to breathe those in. So I'm going to get my iron heating up here, and I'll model one of these connections closely and then speed through the rest. As my iron heats up, I usually start to do some maintenance right away. So you always want to clean the iron frequently, before, during, and after use. As this is warming up, I'm going to start to try to melt some solder onto it, or see if I can get it melting into the tip tinner, just to kind of see where the temperature is at. Also going to tighten this up. It's starting to loosen. And if you have a temperature readout on your iron, something in the range of 350 to 400 degrees Celsius is pretty good. All right, so go through a few rounds here, melting some solder onto the tip, making sure it flows around, using the brass wool to further distribute that and clean it off a few times. Don't want to worry about wasting solder here. We got plenty. Okay, that looks happy. First, let's do the red and the black. So the stranded wire, I'm going to twist it together so it looks more like a solid core wire. Throw that in my helping hand here. What we're going to need to both the stranded wire and the solid core wire, what we're going to need to do is pre-tin them, T-I-N. That's where we just melt solder onto both pieces. Once we have that, we can then hold them together, remelt that tin solder, and get those to then stick together. I find that to be an easy way to attach these two different types of wire when you can't easily twist them together. So to do the stranded wire here, proper technique, I clean as I pick this up, melt a little blob of solder onto the iron tip, hold that underneath the wire so that the wire gets as hot as the iron was. Now I can melt solder right into the wire. I'm not trying to paint or drag the solder with the iron onto the wire. That's a big mistake. We're trying to get that hot enough that it'll melt the solder directly. Let's do the same thing with our solid core wire here, and then we'll be able to attach them together. All right, that one's done. And with solder, it tends to have really low melting points here. It cools off quickly, so you can touch these fairly quickly. Those look good. So last step here, I'm going to get my iron ready with a blob of solder on it. Hold these two pre-tinned parts of the wire next to each other, and then hold the iron against both of them, and I should see it remelt the solder. and pull it away there, hold it for a few seconds so that it solidifies. And those are now nicely soldered together. This is exposed here, which could accidentally create a short circuit with something. So a step we'll do at the end here is to put some heat shrink tubing over all these parts. But let me just work through finishing up all the other wires, which I'll speed up. All right, and that is all of the wires extended on there. The next thing will be put a little heat shrink tube on there so that none of those wires can accidentally touch each other and short out. Heat shrink tubing, get in a bunch of colors, different sizes. This little box here is all black, but a variety of different diameters. And I think with most of these, I'll probably go with the second size. And I've got 6 wires, so I'm going to need to cover up a number of these here, but I don't need to use the full length, so I'm going to cut these down into half lengths, and that'll be plenty. The heat shrink tubing, oftentimes if you're connecting wires that are attached to other things, you'll have to remember to put it onto one of the wires before you solder them together. I didn't need to worry about that because the ends of my wires here, there's nothing big on the end, and I'll be able to slide it all the way down. There's plenty of times I've had to desolder it though and add that heat shrink tubing back in. The name implies what this does. Once this heats up, it'll shrink down. I've got a heat gun on my bench here that I'm going to use. But you could use a lighter, you could use a hair dryer, you could even hold it close to your soldering iron as long as it doesn't touch. That should be enough to make it shrink up as well. So always be conscious of what's behind your heat gun here as well. You don't want to be blasting right at your box full of heat shrink tubing and make them all shrink. Be bad. There we go. So that adds not only protection from accidental connections to the wire there, but offers a little bit more strength to the solder connection. I'll go through and do the rest of these real quick as well. All right, there we go. I've got heat shrink tubing on all of our solder joints. You'll notice I made my extensions fairly long here, probably much longer than would be needed to reach any point on the car. But I like, good engineering here. It's going to be always easier to trim these down shorter later than it would be to solder additional extensions on. So as long as you got the wire on hand, might as well do that. The soldering iron I'm done with. I'll set that aside. Let it cool off. Like I already modeled before, it's always good to do some sanity checks here. Sometimes you can have wires that stick together with solder but aren't actually electrically conducting, called a cold solder. So let's check our pairs again, just to make sure that our motors are still working. So this pair was for the steering. Looks like it works in that direction as well as that direction. And then my blue and white were for the driving motor. So it went forward and backwards. So those are good solders, and I'm not going to waste time going any further until I get that working. And it's easier to fix this when there's nothing else on the robot. So always good to do that check. All right, in the next video, we'll talk about where these wires are going to go. How do we control those motors intelligently? Well, first of all, it's going to require this, using some relays. This is a relay module that contains 4 different relays, and we'll talk about how we solder this up and why we want to use it.